Hello students, today we are going to see a new lesson called Magnetism and Magnetic Effects of Electric Current. This is going to be the session 1 and today we are going to see the important topics: Introduction to Magnetism, Earth's magnetic field and magnetic elements, and some basic properties of magnets. Introduction to magnetism. See, magnetism is a physics phenomenon created by moving charges. There are two types of magnetics, what include permanent magnets and another one is electromagnets. Electric and magnetic fields which are combined with each other, and nowadays we call it as electromagnetism. Magnetism is a force that affects magnetic objects in a magnetic field. Let me tell something in more informations about this magnetism. Magnetism is a force, so it is measured by newtons. Magnetism is a non-contact force because it can act without objects touching. Magnetism can be attractive when two opposite poles are near one another, or repulsive when two like poles are placed near one another. Magnet produce a magnetic field. If iron, cobalt or nickel are in that magnetic field, they will be attracted to the magnets. See, many birds and animals have magnetic sense in their eyes using Earth's magnetic field for navigation. Moreover, we have a very nearby in our district, we have a bird sanctuary in Kundankulam. There you can see every year lot of birds migrate from various countries to our Tuticorin district. It's near our Uvari or very near to Kundankulam area. In there, magnetic sensing in eyes for zebra finches bird. It's a bird, you can see the picture of the bird here, which is due to the protein cryptochromes, that is CRY4, which is present in the retina, that means in the eyes of this bird zebra finches. It uses electromagnetic field for navigation. Nowadays we are in use of magnets. Okay, we are surrounded by the magnets. See, this is a microwave oven which uses the magnetic field well. This car, it is totally depends upon the earth magnetic field. We cannot move it as it is. This kind of speakers, okay, nowadays we use this compass for navigation. Even we have a Google map in our mobiles, it also uses the magnets for navigation, the direction. Then this is a picture about a MRI scan. This MRI scan is also used with this magnetic field. Last one, which is we used as a voice material in speakers. This is the system behind the speaker. See, which have a suspension, a basket, a spider, then a magnet is in the speaker box, which helps to listen or to give the sound properly with the diaphragm. So nowadays we are in use of magnets well. Earphones, okay, or headphones. We cannot live with this without this headphones nowadays. All the online classes should be with this headphones. Then Earth's magnetic field and magnetic elements. The branch of physics which deals with the Earth's magnetic field is called geomagnetism or terrestrial magnetism. You can see in the picture the geographic north pole and the geographic south pole of the Earth. See, this is the Earth and this is the geographic north pole and this is the geographic south pole. But the magnetic south pole and the magnetic north pole is little different from the geographic north and geographic south. It is in a little tilted position. You can see in this picture. Then components of Earth's magnetic field. What are the components we can see in the Earth magnetic field? First one, there are three components that are responsible for the magnitude as well as the direction of Earth's magnetic field. One is magnetic declination, another one is magnetic inclination or the angle of dip. The third one is horizontal component of the Earth's magnetic field. In this picture also you can see the magnetic north pole and the magnetic south pole. Actually this is the true south pole and this is the true north pole. This is the north pole and this is the south pole. The magnetic field lines and the axis around which the Earth rotates once in a day. This is the axis which the Earth rotates once in a day. Actually the Earth is fully surrounded by the magnetic like this. Dear students, I have a question. What causes Earth magnetism? Let me explain you. Earth magnetism is generated by convection currents of molten iron and nickel in the Earth core. You all know the Earth is full with the nickel and iron core, and if you dig the Earth very deeper, probably more than kilometers, you can see lot of iron cores are there inside the Earth. These currents make streams of charged particles and the currents generate magnetic fields with the support of this iron and nickel inside the Earth surface. Then the magnetic fields which from the Earth deflects ionizing charged particles coming from the sun, which is called as solar wind, and prevents them from entering our atmosphere. See, due to this magnetic field only, we are very safe from the sun's direct force of attraction using the rays. Then this magnetic field prevents us from the sun's field. Without this magnetic shield, the solar wind could have slowly destroyed our atmosphere, preventing life on Earth to exist. Mars does not have a strong atmosphere that can sustain life because it does not have a magnetic field protecting it, just like as our Earth. The Earth magnetic poles are not aligned to the actual geographic north and south poles, which I mentioned you earlier. Now let us move to see what do you mean by this magnetic declination. See, actually this is the geographic meridian, okay, and this is the declination angle D, which is meant for angle of declination. This is the original and this is going to be the declination angle. The magnetic declination is defined as the angle between the true north and the magnetic north. On the horizontal plane, the true north is never at a constant position and keeps varying depending upon the position of the earth's surface and the time. Next one, magnetic inclination. See, the magnetic inclination is also known as the angle of dip. It is the angle made the horizontal plane of the earth's surface and the magnetic equator. The angle of dip is 0 degree, and at the magnetic poles the angle of the dip is 90 degree. In this picture you can see our earth surface, which is having a magnetic fields, and this is our earth, and this blue lines shows its vast. Then our planet is nested in the center. Actually it is trapped with high energy. In a new study, our scientist shows very vital informations for us. This shows our planet is totally covered with immense of radiations. Now let's see the horizontal components of the earth magnetic field. There are two components to explain the intensity of the earth magnetic field. One is horizontal component H, another one is vertical component V. See, in this picture you can see the geographical equator, the magnetic equator, the geographical meridian and magnetic meridian. It little differs from the geographical equator and the magnetic equator, and this shows the angle of declination. Okay, and this is differ from the geographical meridian and magnetic meridian. Now the component of Earth's magnetic field along the horizontal direction in the magnetic meridian, this horizontal direction magnetic meridian is called as horizontal component of the Earth's magnetic field, which is denoted by BH. So let BE be the net Earth's magnetic field. Hereafter we are going to use BE as the Earth magnetic field and BH as the horizontal component of the Earth's magnetic field. Now the net Earth's magnetic field at a point P on the surface of the Earth and BE can be resolved into two particular components. One is horizontal component, BH is equal to BE cos I, and BV is equal to, that is vertical component, is equal to BE sin I. That is, we have dividing the equation 2 by 1, we get tan I is equal to BV by BH. That means the vertical component divided by the horizontal component. Now let's see at magnetic equator. The Earth's magnetic field is parallel to the surface of the Earth, that is in horizontal direction, which implies that the needle of magnetic compass rests horizontally at an angle of dip, which is I is equal to 0 degree. If you substitute I is equal to 0 degree in the above equations, we get BH is equal to BE cos 0 degree. As you know, cos 0 degree it's 1, so BH is equal to BE. And if you substitute for the vertical position, BV is equal to BV sin I 0 degree, then sin 0 degree is equal to 0, so BV is equal to 0. This implies that The horizontal component is maximum at the equator and vertical component is 0 at equator. Now at magnetic poles, the Earth's magnetic field is perpendicular to the surface of the Earth, that is, it's vertical, which implies that the needle of magnetic compass rests vertically at an angle of dip. Here the angle is 90 degree, so BH is equal to BH sine 90 degree. Sine 90 degree is equal to 0, so BH is equal to 0, and BV is equal to BE sine 90 degree. We know sine 90 degree is equal to 1, therefore BV is equal to BE. This implies that the vertical component is maximum at poles and horizontal component is 0 at poles. Remember students, the last 2 points, that means this implies and this implies are very important one word questions. Now thank you students. Study the lesson well because it's totally a different topic. Some of you are confused with this electrostatics and magnetism. If you are well versed with your book, you can get the right answers.